All right, ladies and gentlemen, welcome back, and big congratulations for surviving Lesson 7. Not an easy one. I'm glad to see you guys are able to make it today for Lesson 8. Wish I had some good news for you. I wish I could say that Lesson 8 is going to be a little bit easier, but I think we're headed for some similar choppy waters here, and let's just do our best and put our nose to the ground here and see what we can come up with. So today, Lesson 8, we're going to do estimating quantities. Okay, and before we get started, I just want to go over a quick example because we're going to see some situations like this, and sometimes students aren't exactly sure what to do. So right here I have two buildings. I have the skyscraper here that's 720 feet, and this barn over here that's 18 feet. And what I want to know is how many times larger is the skyscraper than the barn? And again, some students aren't quite sure exactly how to go about doing that, what operations involved. But when we want to know how many times greater something is, what we're actually going to do is use division. So what I'm going to do is I'm going to take the larger item. Which one of these guys is bigger? Well, it's the skyscraper. So I'm going to take 720 and I'm going to divide it by the height of my barn. And when I do that, I get 40. So 720 divided by 18 is 40. So therefore, the skyscraper is 40 times larger than my barn. So what I'm trying to get at here is whenever they ask you how many times greater or how many times bigger something is, I know they use the word times, but what they're looking for there is some division. You're going to see that in today's lesson. Okay, so let me take you to the beginning here. So let's take a look at the first example. Now, in your notebooks, go ahead and open. All I really want you to do is write down the numbers. You don't have to copy down this problem, just kind of copy down the numbers with what I do here. Okay, so it says in 1723 the population of New York City was approximately 7,248. By 1870, almost 150 years later, the population had grown to 942,292. We wanted to determine approximately how many times greater the population was in 1870 compared to 1723. So what we're going to do is we're first going to write down 7,248. That's the population of New York City. Okay, so you can see I've written down the New York City population in 1723 and the New York City population in 1870. If you want to hit pause to just write this down in your notebook, go ahead. Okay, so what I want to do is I want to approximate these numbers. I want to approximate it using the power of 10. So this is kind of what we did yesterday. So I can see that I have 1, 2, 3, 4 digits. So to approximate this would be 10 to the 4th power. And here, to New York City in 1870, you can see I have 1, 2, 3, 4, 5, 6. So this is going to be written as 10 to the power of 6. Now, like we did in the example right before this with the skyscrapers, I want to know how many times greater New York City's population is in 1870 compared to 1723. Well, again, I want to use division. Okay, so I want to use division. So I'm going to divide, now just try to keep in mind here, these are dates, not numbers here. So I'm going to divide the bigger amount, which was the 1870. So I'm going to put 1870 on top. See if I can get this color coordinated. Divided by my 1723 number. So that's going to be 10 to the 6th, which was 1870 divided by 10 to the 4th. There. And we learned from our previous unit that to divide exponents, we're going to subtract. So 6 minus 4 is 2. So it would be 10 to the 2nd power. And 10 to the 2nd power is 100. So in 1870, it was 100 times greater than the population compared to 1723. Okay? Okay, so let's take a look at another example, and you're going to go turn to your packets here and do exercise 1. This is on page 28 in your notebook, and it's exercise 1. So go ahead, I'll read it. It says, the Federal Reserve states that the average household in January of 2013 had $7,122 in credit card debt. About how many times greater is the U.S. national debt, which is $16,755,133,009,522. We write each number to the nearest power of 10 that exceeds it, and then compare. So this is very similar to what we did in the last problem. So what we want to do is first put these into the power of 10. So let's first do 7,122. And again, there are 4 digits. 1, 2, 3, 4. That's going to give me 10 to the 4th. And then the big number, the 16 trillion. Let's see here, 3, 6, 9, 12, 13, 14. So I'm not going to rewrite that number, so it's just going to be 10 to the 14th power. So what am I going to divide? Well, I'm going to take the bigger number, which is the U.S. national debt, and I'm going to divide it by our household. And so that's going to give me 10 to the 14th over 10 to the 4th. Do your subtraction. 14 minus 4 is 10 to the 10th power. Okay? So when you do that, you get 10 to the 10th power greater than the U.S. household. Okay? So take a look at the next example. Oops. And this is going to be in your notebook. This is not in your packet. So go back to your notebook here. Okay, so we're going to spend some time doing example 2 and example 3 together. Then I'm going to send you guys off on your own to do a couple of problems in your packet. So what we're going to do now is take a look at example 2. And again, you don't have to write this down. You can just write down the numbers when we get there. It says, let's compare the population of New York City to the population of New York State. Specifically, let's find out how many times greater the population of New York State is compared to that of New York City. The population of New York City is 8,336,697. Now what we're going to do is we're going to round that to the nearest million, which gives us 8 million. The population of New York State is 19,570,261. And we're going to round that to the nearest million, and that rounds to 20 million. Now, what we're going to do is we're going to write these as single-digit integers times the power of 10. Now, this may sound confusing, but you'll see it's really not that bad. What you have to do is just count. So, here's how you do this. We know that the first placeholder here is 0 power of 10. Hopefully I can write big enough here. The next one is 1, 2, 3, 4, 5, 6. So this is now going to tell me that it's a 6 placeholder. So watch what I do here. I'm going to write this as 8 times 10 to the power of 6. So in case you didn't quite understand what happened there, let's take a look at 20 million. Again, I'm going to write that as a single digit integer times the power of 10. So watch what I do. I start with 0, 0, 1, 2, 3, 4, 5, 6, 7. So hopefully you can guess that I'm going to take the single digit that's way out there to the left. So I'm going to take 2 times 10 to the power of 7. So now I need to find, well, how many times bigger is the population of New York State compared to New York City? So when we, like we did before, we need to use division. So I'm going to put the state on top because that's going to be larger than New York City. So the state is 2 times 10 to the 7th, and this is what you want to be writing in your notebook. And the city is 8 times 10 to the 6th. Now, because of the laws of multiplication and the properties of multiplication, I can kind of split these things up because all we're doing here is multiplying between the two numbers here, and you'll see what I mean in a second. So what I'm going to do is just kind of split this up. So I'm going to rewrite this as 2 over 8 times 10 to the 7th divided by 10 to the 6th. And because we're multiplying, that allows us to do that. So now, 2 divided by 8, which is 1/4, is just 0.25 times, do your subtraction, 7 minus 6 is 10 to the 1st, or just 10. And then another way of writing that is 0.25 times 10. And 0.25 times 10, if you need a calculator, is 2.5. So the state of New York, the state population is 2.5 times larger than New York City's population. Okay, and you'll see this part here might be new for a lot of you, and you'll see as we go through a few more examples of what I'm talking about. Okay, so let's take a look at another example here. Example 3. So there are 9 million devices connected to the internet. If a wireless router can support 300 devices, about how many wireless routers are necessary to connect all 9 billion devices wirelessly? Okay. So, again, we want to do this finding the single digit power of 10. So the first thing I need to do is write out 9 billion. So when I write out 9 billion, it looks like the following. So again, I need to write this in a single digit power of 10. So I'm going to start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And from the previous example, I know I can rewrite this, and it's just kind of coincidence that they're both 9s out here. I'm going to rewrite this as 9 times 10 to the power of 9. So you can see we get about 9 times 10 to the 9th power devices. Now, what about routers? Well, if a wireless router can support 300 devices, I want to know how can I rewrite this in standardized form here. Not standardized form, but single digit. So 0, 1, 2. So that is going to be 3 times 10 to the 2nd power. So if I have this many devices, and each router can hold 300 devices, how many routers do I need? Well, I need to divide this. So I'm going to take 9 times 10 to the 9th divided by 3 times 10 to the 2nd. And again, split these up because we have that multiplication there. We can do 9 divided by 3 times 10 to the 9th over 10 to the 2nd. And that works out to be 3 times 10 to the 7th, because 9 minus 2 is 7 here. Okay, and when you actually write it all out, 3 times 10 to the 7th is 30 million routers are necessary. Okay? Alright, so what I'd like you guys to do is go to your packets right now and go ahead and try exercises 2, 3, and 4. So go ahead and hit pause. Okay, in exercise 2, you can see I wrote 3 million at 3 times 10 to the 6th. I'm going to take my K-12 divided by my middle school. When I do that, I set up my two single-digit powers of 10 here. Then I'm going to separate them. 3/8 times 10 to the 6th divided by 10 to the 2nd. 3/8 is 0.375. To your subtraction, you get times 10 to the 4th. That all works out to be 3,750 times greater. Okay, in exercise 3, you can see here I've got the universe on top, naked eye on the bottom. 3,000 is written as 3 times 10 to the 3rd. Split them up, 6 divided by 3 times 10 to the 22nd over 10 to the 3rd. 6 divided by 3 is 2. Do your subtraction here. 22 minus 3 is 19. So my final answer here is 2 times 10 to the 19th. And this number is so big, we're just going to keep it in this form here, because this number's got at least 19 zeros here. Okay, so take a look at exercise 4. Okay, a lot going on here in exercise 4. So we want to find the percentage of the total population that is left-handed. So I'm going to estimate left-handed, which is 682 million to 700 million. I'm going to write that in single digits, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8. So I get 7 times 10 to the 8th. So to find the percentage, I need to take the number of left-handers divided by the total amount of people. So there's my single digit power of 10 divided by my total population. Now here's what's interesting. The 7's actually go away. 7 divided by 7 is just 1, so they disappear. So that leaves me 10 to the 8th divided by 10 to the 9th. So I'm going to subtract 8 minus 9, which is my negative 1, which gives me 10 to the negative 1. And we know that since it's negative, it drops to the bottom. Well, what is this? Well, this is 1/10. And 1/10 can be written as 0.1. And 0.1 as a percent, multiply that by 100, is 10%. So 10% of the world's population is left-handed. Go ahead to part 2.